All right, today we're diving into a breakthrough that could completely flip the script on how AI works. We're talking about making it ridiculously more efficient. Imagine a future where incredibly powerful AI doesn't need a supercomputer to run. A future of AI without all the heavy lifting.
Deep down, at the very core of today's most powerful AI models, there's this single, massive bottleneck. It's a mathematical problem that's just hogging all the power and all the memory. So this is the story of how a team of researchers is planning to just smash right through it. So it really makes you wonder, right? What if the very thing that made modern AI so powerful is actually its biggest weakness? What if we've been building these incredible digital brains on a foundation that's just fundamentally inefficient?
Okay, let's meet our main character. Or maybe our villain, matrix multiplication. You can just call it MatMul. Think of this as the engine inside almost every modern AI. It's constantly multiplying and adding up these enormous grids of numbers. But here's the thing, this engine is a total gas guzzler. It is, by a long shot, the most expensive, power-hungry part of any big AI model today.
This brings us right to the heart of AI's really expensive math problem. And to really get why the new solution is so brilliant, we first have to understand how we even got stuck in this mess in the first place.
Well, a big part of it is something called the hardware lottery. You see, AI didn't necessarily pick the smartest or most efficient way to think. Nope, it just evolved to use the math that our computer chips, specifically GPUs, were already amazing at. And since GPUs are absolute masters of matrix multiplication, AI models got hooked. It became a full-blown addiction, but one born out of convenience, not actual necessity. So, if MatMul's the problem, what's the fix? Well, researchers are proposing something pretty radical, a new kind of AI model that just gets rid of it completely. They're building a whole new way for AI to think.
So here's the big idea in a nutshell. On the left, you've got your traditional AI, just chugging away, doing millions upon millions of complex multiplications. But the new MatMul-free approach on the right, it just tosses all of that out and replaces it with stuff a computer can do way faster and with way less energy. Simple addition and subtraction.
So how on earth do they pull this off? Two really clever tricks. First, they put the model's brain on a diet. All of its internal numbers, its weights, are simplified down to just three possible values, +1, -1, or 0. Suddenly, multiplication becomes dead simple. You either keep a number, flip its sign, or ignore it. Second, they swapped out the model's most power-hungry component, the attention mechanism, with a brand new, super efficient part that doesn't need to do all that heavy lifting. Okay, but being efficient is one thing. It means nothing if the model can't actually perform. So the million-dollar question is, can this new stripped-down model actually go toe-to-toe with the heavyweights?
I mean, that's what you're thinking, right? We've put this AI on a radical computational diet. We took away its favorite food, MatMul. So, does it still have the smarts to do complex stuff?
Well, let's look at the numbers. This chart puts a standard AI model, a transformer, head-to-head with the MatMul-free version at a few different sizes. That column on the right shows how well they do on new tasks they've never seen before. And look at that. At every single size, the MatMul-free model is right on its tail. The performance is incredibly, almost unbelievably close. And here is the absolute key. It doesn't just work, it scales beautifully. As the models get bigger and more powerful, that tiny little performance gap between them actually starts to shrink. This proves this whole MatMul-free thing isn't just some neat trick for small models. It's a real, viable path forward for the huge AI systems of the future. Okay, now for the real payoff. Performance is neck and neck, sure. But what about efficiency? Because this is where the MatMul-free approach doesn't just win. It blows the competition out of the water.
First up, let's talk about training. This new architecture slashes memory used during training by up to 61%. That is a massive, massive saving. It completely changes the cost and accessibility of building powerful new AI models.
But the savings when you're actually using the model, what we call inference, are even more mind-blowing. The MatMul-free model needs over 10 times less memory to actually run. That's not just an improvement. That's a revolution.
And this chart just says it all, doesn't it? I mean, look at that difference. To run a big 13 billion parameter transformer, you need a beast of a machine with almost 50 gigabytes of memory. The MatMul-free version, a little over 4. That could run on a good gaming laptop, maybe even a smartphone in the near future. It's a total game changer.
So where is all this going? What's the end game? Well, the researchers themselves point towards this incredible new frontier, neuromorphic hardware. These are basically computer chips that are designed from the ground up to work more like a human brain. And when you pair this brain-like software with that brain-like hardware, just wow, the results are insane. Compared to running a standard model on a mobile GPU, the MatMul free model on one of these neuromorphic chips is over 4 times faster and an incredible 10 times more energy efficient. This is what the future of AI looks like.
So let's zoom out. What does this all really mean? We're not just talking about a faster algorithm here. This could literally be the dawn of a new era for AI, one that thinks and computes in a fundamentally different and better way.
I mean, the implications are just huge. We're talking about incredibly powerful AI running privately, right on your phone, without needing a connection to the cloud. Think about the massive energy savings for the planet as AI becomes more sustainable, green AI. And, of course, making it drastically cheaper to build and run this stuff will open the doors for so much more innovation from everyone.
Which leaves us with this one last big idea to chew on. For decades, we've been focused on simulating intelligence, making AI act smart. But maybe this is the first real step towards mimicking its incredible efficiency. Maybe the future of AI isn't just about being smarter, but about being smarter with a whole lot less.